Hey guys, welcome to my channel again. Well, I'm Sai Krishna. So, what's topic we are going to learn about? Well, today our topic is going to be charge transport through polymers. Well, I'm very excited about this presentation, so let's not waste any more time and begin our presentation. First, we will know what are our objectives. Before that, I should let you know who I am, right? So, as you know, my name is Sai Krishna. I am a student who is studying data science specialization at IARU. So, what are the objectives of today's presentation? Let's focus on that. First, we will introduce ourselves to polymers. Next, we'll understand the conducting polymers. So, first we will understand what is a polymer actually, then we can go deep into by knowing what are conducting polymers, a part of polymers. So let's start by introducing ourselves to polymers. Introduction to polymers. The first question is, what is a polymer? As you can see, a polymer are very large molecule made when hundreds of monomers join together to form long chains. Now, the word polymer comes from the Greek word poly, which means many, and meros means parts. If my pronunciation is wrong, I'm really sorry. So, polymer is a word which is made up of two Greek words. First is poly, second is meros. By this slide, we are completed answering the question, what is a polymer? Next is types of polymers. A polymer whose backbone chain is essentially made of carbon atoms is termed as organic polymers. So, a polymer which has a carbon in it is simply an organic polymer. Example, cellulose proteins. Okay. Next, a polymer that does not have a carbon atom in its chain is termed as inorganic polymer. Example, glass, silicone rubber. Now, this question will definitely rise to everyone, or at least some of you. So, if organic polymers are the polymers which contain carbon, that does mean all unnatural polymers are not organic polymers? Well, it was like that many centuries ago, but we can also synthesize polymers which can contain carbon in them. So, natural and synthetic, if both contain carbon atom, then they are called as organic polymer, and if they do not contain our carbon atom in their chain, then it is considered as an inorganic polymer. Okay, so we completed types of polymers. Basically, there are only two types, organic and inorganic. Next, introduction to polymers again. Properties of polymers. So what are the properties of polymers which make them a special, what you might say, a special class? Yeah, it's a right word. So the first property, they are lightweight. Second property, they have high strength. Third property, they are very flexible. And fourth property, they are chemically resistant. The best example that you can take which contains most of these examples is the plastic chair which is present at your home. It's lightweight, yes or no? Yes. But it has high strength, yes or no? Yes. It is also somewhat flexible. When you try to stress it, it bends. So it's also flexible. Moreover, it is resistant to chemicals. For example, when you apply Dettol to your skin burns, obviously. But when you apply Dettol or any other chemical, for example bleach, let's take bleach. Does it affect the color or the property or the stance of the chair? No, right? So these are chemically resistant. That's why polymers are widely used because of their magical properties. I must say, polymers are one of the stepping stones for our modern society. A very important point that you must remember. Next. Now, we have completed answering the question, what is a polymer, types of polymers, properties of polymers, etc. Now it's time to know what is a conducting polymer. So a conducting polymer is essentially part of the polymers classes, but what makes it very special? At the beginning of the slide, I have mentioned next generation conductors. It's very true. Conducting polymers may become conductors at your home in coming future, so it may replace copper wires. So let's understand what are the reasons for which I'm stressing that these may become the conductors that we may use in day-to-day life in future. So let's know about them. Conducting polymers are those polymers that conduct electricity due to delocalization of pi electrons. Now if you studied your 7th, 8th, 9th, 10th properly, especially chemistry, you can understand what is delocalization of pi electrons. It simply means electrons are unpaired and are ready to move. So these electrons are not part of sigma bond but of pi bond, which under the influence can travel throughout the chain. That is delocalization of pi electrons in layman terms. So what are the examples of conducting polymers? First is polyacetylene. Second is polyaniline. Okay, next. So someone must have discovered conducting polymers, right? So who are they? Let's find out. Initially, I too thought, before researching on this topic, polymers were used as insulators in electronic industry. Why insulator? Take your remote. At least take your phone. Your phone also contains plastic in it, but it doesn't give you shock even though it has a battery. Let's take a powerful battery. For example, mosquito bat. It also has a plastic holder, but it doesn't give you an electric shock. Or switchboards. Switchboards are also made of plastic, which is a polymer, but it doesn't give you electric shock. So essentially what you can understand that plastic or other polymers are mostly insulators. But conducting polymers were discovered in late 70s, that is 1977, not 17th century. If it were discovered in 17th century, we may be using those conducting polymers and thrown out copper wires altogether, but these are discovered recently, that is 1977, by 3 great scientists. To be frank, they are chemists. First, Alan Heeger, not Levin Heeger, Dr. Hideki Shirakawa. It's not Shirkumba, it's Shirakawa. He's a Japanese person. Okay. Next, Alan MacDiarmid. I know my pronunciation is idiotic. Please bear with me. So these 3 guys essentially discovered conducting polymers. Now, due to their contribution to our modern society, they have received Nobel Prize in Chemistry in the year 2000. So, if they have received Nobel Prize for this discovery, that must mean it's a very important discovery. Yes, it is. So let's see these their beautiful faces. Alan Heeger, Hideki Shirakawa, and Alan MacDiarmid. These 3 guys found conducting polymers in 1977 and are Nobel laureates. Unfortunately, Hideki Shirakawa is not with us anymore. Now, what are the types of conductive polymers. Depending on type of charge transport by carriers. Now you may say, there is only one charge, that is electrons. Sorry. Electrons are the reason we have electricity. But he is saying charge transport. Charge can be transported as ions, and ions have different properties. So, first is ionically conductive polymer. That is, it's a used solid state electrode in batteries. So you might have heard solid state batteries are the next generation of batteries which will transform the electrification of everything. So today, the batteries that we possess have a liquid electrolyte. If it has a solid electrolyte, then its performance, its capacity increases. So if the charge transports through a solid state electrolyte, then that polymer is considered as an ionically conductive polymer, and examples are polyethylene oxide, which contain lithium perchlorate, that is LiClO4. So if you know how to link. Without this discovery, I guess solid state batteries were far off, right? So because of this discovery, we've been able to design and manufacture early prototypes of solid state batteries. Next, electronically conductive, that is filled conductive polymers, that is intrinsically conductive polymers. Example, liquid electrolytes. That's it, the things that we have mostly. Polymers can also be liquid. Okay, understand that. Even Fevicol is a polymer. I know it's true, but it's very stunning to know, but Fevicol is also a polymer. Let's move. Understanding the conducting polymers. No, conditions for conductivity. So we must, if there are some polymers which are conducting, what conditions make or what properties make them special from other polymers? In this slide we are going to learn that. First, conducting polymers should consist of alternating single and double bonds, which is known as conjugated double bonds. I know you didn't understood because we all didn't study 8, 9, 10 properly. I know that. So let me give me an explanation. I'm becoming like you guys. In conjugation, the bonds between the carbon atoms are alternatively single and double. Every bond contains a localized sigma bond, which forms a strong chemical bond. In addition, every double bond also contains a less strongly localized pi bond, which is weaker. So, conjugative. First is single bond, after is that is double bond and single bond and again double bond. So conjugative arrangement of single and double bonds in a chain will result in conjugation. So if a polymer has to be a conducting polymer, its chain must have conjugated double bonds. Okay, that is a consecutive sequence of single and double bond throughout the chain. The polymer has to be disturbed. The process is known as doping. It's not doping, it's not that doping, it's another type of doping. But essentially they both do same thing. They inject something to get something out. Okay. So either by removing electrons from oxidation or inserting them into reduction, into the material, which is reduction. So essentially doping is same, but use cases are different over here. Okay. Now, let's go deep, let's understand it by going deep into doping. Doping is the process by which the conductivity of polymer may be increased by creating a negative or positive charge on the polymer backbone by oxidation or reduction. Simply, he is creating potential difference in the polymer so that to allow electrons to move. Electrons only moves when there is potential difference. What is potential difference? Difference in charge. So it will create a positive or a negative charge in a polymer, making it more conductive. Simple, right? Now, there are two types of doping. First is oxidation with using halogens, that is P doping. Next is reduction with alkali metals, that is called N-doping. Okay, I guess you have understood. Yes. Now, what are types of doping agents? So there are some different types of doping agents. By using them, we can dope our polymers. First is neutral dopants, which do not contain any ionic charge, that is bromine, sodium, potassium, sulfuric acid, ferric chloride. Next, we have ionic dopants, which consist of some charge, that is LiClO4, FeClO4. Next is organic dopants, simply organic polymers, CF3COOH, CF3SO3Na. Don't ask me their name, it's very hard. Next, polymeric dopants, that is PVS and PPS. Don't ask me abbreviations, they are very hard. Let's move on. Plot of doping versus conductivity. Now, if you observe carefully, as you dope, its conductivity increases, but at a certain point, even you increase the effectiveness of doping, the conductivity will not increase. So, you can dope till the polymer lets you. After that, you cannot. So, every polymer has a certain limit for conduction, and that can be attained by doping. So there is no sky limit, there is a certain finite limit in a polymer for conduction. So I have said next generation conductors. Let's see. Conducting polymers have many uses. The most documented are as follows. Anti-static substances for the photographic film. Simply, photographs will be better. Corrosion inhibitors. Copper gets corroded, polymers don't. Compact capacitors. Copper capacitors are bulky like Hulk. Compact capacitors by polymers are like Ant-Man. Simple. Next, anti-static coating will kick out static electricity, thereby reducing fires at petrol stations. Electromagnetic shielding for computers. Sun will not do anything to us. Simple. Smart windows. Even windows are getting smarter due to polymers. When you will be? That question is asked by my mother also. Okay, let's leave that. So these are the applications. Understanding the conducting polymers advantages. They are good insulators of heat. Same insulators. Can perform any shape. They can be formed into any shape. Now they have very low density, so easy to carry, lightweight, high volume. Next, they require low finishing cost. They are polymers, dude. They are plastic. I can make a plastic toy with my hand. Understand? They require low finishing cost. Yes. Their toughness and ductility is good. Enhanced flexibility. You know that. Solubility in organic solvents. Variable processability. So, the biggest problem with copper, it only decomposes in soil and at very high time. It takes a long time. But if you are able to dissolve it in organic solvents, then you can also use it in chemistry. That implies, it's very simple, even the polymers can make liquid electrolyte, which is already present in our batteries, more efficient. Disadvantages, let's know about them. Only one disadvantage that I can find: limited mobility of charge carriers. Why? Due to their intrinsic physical properties, that is limited mobility of charge carriers, the performance of polymer electronic products lack the speed of its silicon counterparts. Research is still ongoing to increase performance for more complex functionality. To be able to improve performance, one should be able to distinguish between problems introduced during preparation, intrinsic material properties, and device characteristics. As I have said earlier, there is a certain finite limit for conduction. Due to that certain finite limit of conduction, the conductivity capacity of a polymer is greatly limited. So, summary, introduction to polymers completed. Next, understanding the conducting polymers completed. Thanks for listening. Let's meet up in next time.